All right, so welcome back. Welcome back to my YouTube channel. Welcome back to this YouTube channel. Right, so in the last video, yeah, you know what we did in the last video. So over the past few videos, sorry. So over the past few videos, we have we have covered about image classification, especially problems of classifying between images, finding differences actually, finding differences between classes. So finding features in videos or images, sorry. So we are able to build models that are able to find the differences between images, right? So differences between features and patterns in images using something called convolutional neural networks. So I'm going to okay. So and in this section of the videos, we are going to solve a problem called object detection, right? So we should be, we learn to build models, right? To make neural networks detect objects, not only a single object in an image, but multiple objects belonging to multiple classes. And the problem is very simple, detecting each object and classifying them. So it just think of this problem. So what is object detection or localization means? So let's say you have an image, and let's say there is an object, the main important object, let's say, or an object belonging to one of yours one of your required classes. So there is an object that is belonging to a required class. So let's say there is an object, maybe the required class has a dog. So let's say there is a dog image, just for learning purposes. So what we are going to do is, in the normal CNN model, we have looked at detecting dog. Let's say we have looked at model taking this input and detecting a dog. So how can it able to detect it? Well, we'll do some CNNs and all that. I have covered it in the past few videos. So the new problem is to be able to localize where this dog is staying. So to be able to detect the coordinates of the position of this dog. So where is the dog is? So as you might know, in human vision, so like if you are watching me, humans are not only able to detect objects, right? So detect what they are. We are also able to understand what the image is. So we are going to understand everything about image. So this is just a part of understanding the image. The part of understanding is an image is detecting where the object is staying, right? So where the location of the object in the image, that is a problem of object detection. So if I just give this problem to any person who have already have idea with image CNN, for example, you might say we can just input this in a CNN, right? So you might introduce a new method, right? So we have CNN, and then what we'll do is we'll just, rather than just predicting the class, so let's say these are the output neurons. Not going to write all the values. So let's say we have so you might just suggest this method, right? So I just suggest adding three more neurons. So remember, in classification, right? So, or let's say I'm going to add, okay, let's say there are three classes. So let's say there are three possible images or three possible image types. So we are going to have three neurons for predicting the type of the image. And you might say we'll have another four neurons. Let's say we'll just create another four neurons, and each neuron is uh, predicting the value of, let's say a coordinate, right? So let's say this neuron is predicting the rightmost coordinate, or etc. So you understand the idea, right? So you might come with this idea of adding more neurons to the output layer, and whereas each added neuron will predict one coordinate of this rectangular box. So that is an idea you might suggest, but I'll tell you what is the problem of this architecture. You might just say, so I'm just going to repeat what I said here. So you might just say that, to solve this problem of object localization, to detecting the position of an object. So you might just say we can just add four neurons, and we'll have three neurons for classification between three classes, right? So each neuron is going to predict the probability of the object being um, in each respective class. And then we are going to have four more neurons, whereas each neuron is um, predicting the coordinate of this image. Well, that is a really good um, architecture for object detection, but the limitation is, right, so let's say you have two images. Let's say you have a dog and a cat. What are you going to do? Let's say we have two dogs, or we have two dogs. What are you going to do when you have two dogs, right? So if you want to detect two dogs, right, so we have to have two boxes, right? So uh, that then when we are solving that problem, when where we have multiple images or um, multiple results. So we have, let's say we have two dogs here. Our model is not going to work, right? So we are not going to get. So let's say we have four more. Let's say we add four more neurons. Okay. Let's say you might just say we add four more neurons, but that is a very bad idea, right? So because let's say you have another dog, we are not just going to add, right? Or we have only one dog, so we are going to bust this architecture. So this architecture does not work, adding more neurons to this final layer, in order to predict the coordinates. It does not work. This architecture clearly does not work, because the number of objects we can appear that can appear in an image is endless, and we cannot determine how many objects are going to, how many objects that we need will appear in an image. So that is where these systems fail us. That is where we don't want to use these kind of systems, right? So now adding more neurons to this last layer is not going to work. So the problem, so we can use this CNN when there is only one object. So this uh, like the problem that this architecture can solve is called object localization. So object, there are two terminologies: object localization and object detection. So object localization means detecting single object. So detecting the position and the class of a single object, single required object. Whereas in object detection, there can be multiple classes and multiple images, multiple objects. So this is the problem that we're going to solve: object detection. We just came into the problem. So now I'll discuss some of these approaches, and in the future videos also will elaborate on these approaches. I'll decide what we should, what I'll teach. I'll teach the things that you need, that you have like really need to learn. So if you want to learn more about them, if you want to learn more about object detection and all that, there is an amazing computer vision channel. I'll share it in the description. Just make sure to check out. So these are some of these um, solutions that have been proposed to solve this problem of object detection. So the first one is sliding windows approach, which I'll just so these approaches are not that good. It are not used in the current world. In the current world, I'm just going to give you a spoiler. In the current world, current object detection models, YOLO algorithm is used. You only look once. I'll also touch that algorithm a little bit in this video, and then in the future videos, we are going to cover more about these algorithms. So first, the sliding window approach. So what is sliding window approach means? Let's say we have this image, right? A common image. This image might have, let's say, for example, this image has a dog here, right? And then let's say dog here. So what this approach is, well, we have a window here. We're just going to crop that image, right? So we have, let's say we have this full image, and we're going to take a part of this image, and we're going to run a CNN classifier, right? So this CNN is going to predict, this CNN is going to predict some things. So this CNN will predict if there is an object in it, right? So let's say, is an object in this crop of the image, right? So does an object exist in this crop? And then we are going to shift to this slide. We are going to shift this slide. We are going to shift this. I'm just going to divide that, and then until somehow we can come to this object. So we have, let's say this image or this crop. Let's say this is, or let's say this box. So we will slide this filter, or we'll slide this crop. So we are going to crop the image one by one, and then hopefully we are going to get through a crop in which the object exists. So there is an absolute flaw here, because we can't figure the size of the image. The image can be very small. Sorry, the object can be very small, or the object can be very large. So we can predict the size of the object. So there is a flaw here. So let's say the object is, no, I'm just going to draw a new figure here. Let's say the object is very large and we have small crops. It's not going to work. Let's say we have large crops and very small image, then the CNN might not be able to detect this image. So that is why this approach is not so good. So again, I'm going to repeat what I said in the sliding window approach. So we are going to have a slide, right? So we are going to slide a crop, or we are going to crop that image in a specific part, and we are going to take consecutive parts throughout this image. We are going to continue this crop. We are going to continue taking a part of this image, and we are going to do that for all of the image. And then we are when for each part we are going to run through a CNN, and we are going to check if there is a object inside that specific crop or part. And second approach is called I think regional CNN. So this idea is actually it is pretty good. So the idea here is, let's say we have an image. I'm going to draw an image, and then let's say we have a dog here. Again, a dog. So let's say you have another dog here. One dog here, one dog here. So the idea is, right. So first, what we are going to do is we are going to divide this image, or get a specific parts of this image using an algorithm called I think selective search. So we are going to use an algorithm called selective search. It's a computer, I think it's a computer science algorithm. So what it does is, like, based on pixel values, like how can we detect objects? Well, difference in pixel values, right? So based on the difference of pixel values, so let me just tell you what that means. So this object here, dog, has very much different pixel values than of the background. So that is the reason we are able to detect a dog here, because of the pixel value difference. So what we are going to do is, using this approach called selective search, we are going to get many like many parts of this image. So we are going to use this algorithm. So we are going to use this algorithm to get many parts of the image, right? So we are going to get different possible parts of this image using this selective search algorithm. Let me just show you what that algorithm does. So these are the steps. So I have this papers with code, a website that I have shared with you, like, right. So this is the follow these are the following step. These are the steps that are followed by this selective search algorithm. So first, it will add all bounding boxes corresponding to segmented parts to the list of regional purposes. So what is going to do is, based on pixel value difference, we are going to draw some boxes. Right? So we are going to have some possible uh, possible possible boxes, or possible detections, or possible parts of this image, which might be the which might be the object itself, so the location of the object. And then we are going to group adjacent segments based on similarity. So let's say we have a dog image here. So let's say this is a possible part, and this is a possible part, and this is a possible part. Right? So all of this has, like, they are very similar. They have the, let's say the dog is brown dog. So they all of these parts are going to have the color brown, and based on the similarity, they are going to add this boxes into a same box. And then this is the first step, and then I'm going to repeat this process until they can get all the parts, get all the important parts. So after they got all the important parts, they're going to run that into a CNN model. All right, so I'll just repeat what I have told you. So in RCNN, let's say in regional CNN, we are going to use this algorithm called selective search, which, like, this algorithm will detect possible parts, or possible objects, or possible squares, or possible crops in this image using an algorithm. So this algorithm will find the difference in pixels, and then it will combine similar segments, and then we are going to get a some like we are going to get many possible boxes, and then each box we are going to send that to a CNN. So this CNN is going to determine if there is an object in the um, in the output of the in the output parts of this selective search um, algorithm. Right, so this is the both of these architectures. These are the both possible solutions, but as I have told you, as I've told you, the current um, like the current model that is used while doing object detection is YOLO. You only look once. So I don't know why that name came from. I think because um I think let's see. So I'll just cover the functionality. I still don't know why that name came. So the name is you only look once. So the idea is, right, so we are going to divide, let's say we have an image, we are going to divide this image into very small parts, very small parts. That's idea is not actually very complicated or very new. It actually pretty like even like anyone might stumble upon this idea. So what this idea is, so we are, as we have said, we are going to divide this image into very smaller sections, right? Like very smaller sections. And let's say we have a big dog here, and then let's say here we have another dog. We're going to draw that. Okay, so as I've told you, so we are going to have this YOLO algorithm. So we are going to first divide this image into very smaller sections. And what we are going to do is we are going to run a CNN algorithm in each of these parts. So we each of these very small parts, very tiny parts. And then we are going to ask this CNN to detect the class probabilities. So we are going to detect which class this part belongs to. So let's say we have three classes, or let's say we have three classes: a dog, a cat, or let's say a dog, a cat, or let's say a lion, right? And then we are going to add another class to define that it is a background image. So we are going to say is the so we are going to go through each of this frame, and we are going to ask the CNN whether it is a dog, a cat, a lion, or the background. And then we are going to do that for each of these frames. I'm going to cover very low here. So just I just wanted to equip you with the basic idea, very basic idea. So actually the purpose of this video is to talk about the problem of object detection. The purpose of this video is introduce you to the idea of object detection, but I have come through this also. I didn't plan it, but yeah, the like for now, think of your all YOLO algorithm as did like converting this whole big image into very smaller sections, and we are going to have a model that is going to predict the class probabilities of each class for every part, of course. So that is the YOLO algorithm. So I think that is it for this, for today's video. I thought of keeping it very small. I thought of keeping this video very small, but I just told it. So thank you for watching, and see you in the next video.